the zero emission vessels transition pathway. That's really about what is needed for the individual vessel to reach the target and objectives of the IMO. So Carlo, please talk us through it.
Thank you very much. Good morning everyone, and thank you very much for having me here today. I work in UMAS, and for those who don't know, is a company that brings together research from University College London and a consultant. It was funded with the aim to help the shipping industry to decarbonize. I would like to start with a very brief story that started in 2012, about 8 years ago, when I was crazy enough to start a PhD research program, and I was looking at the potential use of hydrogen in shipping. In that year, everything that I could find was instead about the use of LNG in shipping. Many predicted that by 2020, there would be about 1,000 vessels by 2020, operating with LNG. There were virtually no studies, no information on any other alternative fuels. 3 years later, in 2015, the Paris Agreement on temperature goals was signed. Shipping was left out from the deal, but several actors started to put pressure on the IMO to face GHG emission reduction. The figure of LNG ships was revised downwards between 400 and 600 vessels. And in that year, I was almost finishing my PhD. 3 years later, 2018, and the IPCC released the report on 1.5 degree that clearly declared that the consequence of going beyond 1.5 degree are devastating for all of us. We need to reduce global GHG emission by 45% in 2030 and falling to zero by 2050 at the latest. At IMO during the same year, during the MEPC 72, it was declared ambition to reduce the total annual GHG emission from shipping by at least 50% by 2050 compared to the level of 2008. There was a significant shift in that period. More attention was on alternative fuels, such as hydrogen or ammonia, and there was a recognition of the importance of these fuels to reach the IMO goals, which was actually in line with the conclusion of my PhD that in the meantime I managed to finish. Today, the call for ambitious climate action is becoming louder and packed with more urgency. In response to that, a number of countries have declared their intention to reach net zero emissions by 2050. The decarbonization of the shipping industry is probably the main topic within the industry. Shipping companies are committing themselves to achieve zero carbon fleet by 2050. Governments are also looking at this. UK government has recently adopted the Clean Maritime Plan. This conference has a dedicated section on each of the alternative fuels. So today, there are less than 200 vessels operating on LNG. And now that I am not doing a PhD anymore, I also make outlook of the shipping industry together with my colleagues in UMAS. And this is what I will also show you today. But before that, I didn't say this story to say, hey, I was writing my PhD, but I said this story because I was lucky enough to witness all these transition, all this discussion. And if we look back, we can at least acknowledge three things. We cannot underestimate politics and the increasing pressure for government to commit to a very rapid decarbonization. The fact that the IMO has only set up a strategy is already creating an impact. Shipping companies are committing themselves to a decarbonization objective. So second, we all know that the shipping industry is using a byproduct of the refinery that nobody's wanted. So it's time to think about a future with this free fossil fuel, or as much free as possible. And third, we know that all other sectors are expected to decarbonize. And shipping needs to contribute to this decarbonization, but most importantly, need also to seek collaboration with other sectors. Because in this way we can exploit potential synergy, whatever is the solution. So speaking about the solutions, so what are the solutions? Well, let's start saying that there are several points of agreement. And one thing for sure is that the shipping industry will face a very drastic transformation. Many seem to agree that energy efficiency technologies, which including wind assistance, shore power, and even operational intervention, are crucial and can help with decarbonization. But increasing energy efficiency is not sufficient to reach the IMO minimum target. There is a need for short, medium-term policy to incentivize the deployment of such energy efficiency in the interventions, although many argue that some of them are already cost-effective. Offset is not the way to go because it puts the industry to extreme economic risk. And also many agree that net zero carbon fuels can be the solution. These fuels are fuels that ensure that not only operational emissions are zero, but also upstream emissions are close to zero. Or alternatively, the sum of both operational and upstream are close to zero. But if these are the point of agreement, what are the point of issue then? Well, this is just a list, maybe not complete list, but this is some of the point of issue. So if net zero carbon fuels, if net zero carbon fuel is the solution, what is the role of biofuels? Considering their issue on sustainability, availability, and competition. Which one of these fuels are the most likely? Is hydrogen, is ammonia, is any other synthetic hydrocarbons? Is one fuel or is many fuels? What sort of competition shipping should expect to this type of fuel? What can be done now? Is the decision of a future fuel needs to be taken now? What's the best strategy to manage the climate risk? Who are the potential early marine adopters? Which region and area are ideal as a test bed for bunkering these type of fuels? And how we can best scale up from that? So what policy we need to put in place that ensure that we are achieving this mid and long-term objective? And more, what is the rule of a sustainable finance for shipping? The finance sector is keen to setting up climate resilient strategy as they face the risk of stranded assets. And finally, how we can use data analytic, big data to help the decarbonization. These are all questions that we deserve more attention. I'm not here trying to answer all of these questions, but what I can say is the following. So what we see here is a graph with these two potential scenarios about biofuel. The blue line is the potential energy demand for shipping in the future, going in the future. So as you can see here, there are two different biofuels scenarios. We think that the high scenarios of biofuels is quite unlikely because it relies on massive change of land use. The IPCC report on land use makes very clear point. We do not have all land to produce these biofuels. And this poses major questions marks related to the sufficient availability of biofuels for shipping, especially as other sectors such as aviation that are relying on that, they are willing to pay a higher price. This is why we think that biofuels actually will play only a minor part in the shipping zero carbon future. If we move on synthetic hydrocarbons, these are fuels that are produced from hydrogen and a source of CO2. That they can be considered net zero carbon if they have an enclosed loop of carbon. They can be synthetic methanol, for example, synthetic LNG on diesel. At the moment, they are expected to be very expensive, as they depend on early stage technology, such as direct air capture, for which future rates of deployment are highly uncertain. Again, we see here two different potential scenarios. I also added the uptake of LNG because many argue that LNG could open up to the market of these type of fuels. However, for the high scenarios, we think that this is very unlikely because it assumes a very high rate of deployment of these early stage technologies. So hydrogen or any hydrogen carriers such as ammonia may have a very great potential, whether they are produced from natural gas with CCS or renewable electricity with electrolyzer or a combination of both or a mix going from natural gas with CCS towards a cleaner way to produce it, which is renewable electricity with electrolyzer. Ammonia at the moment looks favored as it resolves the problem of hydrogen storage on board, and it's associated high cost and space requirement. Also, ammonia can be used in internal combustion engine, which will require a slightly different tweak to the current engine, so some could also be retrofitted. So if we put all of these figures together, we can see here a potential fuel mix scenario. This is in line with achieving a zero carbon emission by 2015. This is just one potential scenario. How exactly this will evolve is still unclear, and it will depend on the evolution of the cost, covering all operations, bunkering, storage, and onboard use. One thing that can be expected is that this fuel will be more expensive. How much more expensive is very much depending on the production cost. But there are evidence that these costs may fall in very, very rapidly. For example, many of these fuels, and key ingredient of many of these fuels is the production of green hydrogen. And a recent study found that renewable hydrogen costs can fall by up to 80% in the next 10 years. This means that the price premium relative to the conventional marine fossil fuels may become very, very small. But to close the gap, we cannot really rely only on market forces. There is a need for policy and coordinated action. This is why I would like to conclude with these few final remarks. We urgently need policy measures that maximize the operational efficiency of all ships. We need policies that enable R&D for these fuels and enable the business case for them. This could be a carbon price whose revenues can be recycled back into the system. We need a commitment to a timetable for the shipping transition to zero carbon fuels so that all relevant stakeholders know what they are working towards. At national level, we need to incentivize for the decarbonization of the domestic fleet and investment for the renewable energy system. At ship level, we need to start to design solutions such that the upgrade costs for likely future fuels are minimized. And finally, cost and compliance remain the main driver behind any environmental strategy. So it's essential that we continue to do everything possible to answer these questions, because this will bring us close to the right answer. But let's be clear, when we can use the most sophisticated technology, we can use the most complex model. This is my job, this is what I do. But we still will be taking decisions with a certain level of imperfect information. So there is a need also for human quality here to find a way to establishing creative and original collaborations, and the ability to radically break with the past rather than using the past as a predictor for the present and the future. Thank you very much.